Okay, so chapter 7. So I know we're going out of order on the chapters. We covered 9 because really this is how the book should be written. Because you are going to have to use Pythagorean theorem this chapter. You do have to use SOHCAHTOA this chapter. So that's why we covered 9 before we get into 7. So like I kind of said at the beginning of the semester, each chapter it's like a different shape. And anything and everything about the shape. So clearly last chapter was all about right triangles mostly. This chapter, quadrilaterals. We're going to talk a lot about quadrilaterals. So you're going to see squares, rectangles, rhombus, kites, trapezoid, all of the quadrilaterals. Today we're going to talk about what exactly is a polygon. Super easy, nothing crazy. And we're going to talk about the angles in a polygon, how you can find the measurement of each angle inside a polygon. So that's really what we're going to talk about today. So you have 2 simple formulas I'm going to give you today. We're going to do some solving for x. But as always, we have to do the vocabulary and fill in the blanks. So what is a polygon, of course? Enclosed curve consisting of line segments. So of course, you're filling in the red there. Connected such that no 2 segments are collinear. Let me give you a second to write all of those words I underlined in green on the blanks in your notes. And of course, once you're done with that, on your notes it says some examples, of course. I just threw some examples here for you. You might think of some other ones. We just did triangles, square, rectangle, octagon. We know what an octagon looks like. I hope we're going to see those today. How many sides on an octagon? 8. Okay, all right, we got it. So again, you don't have to get crazy and write down all of these examples. Put a couple. If you want to put octagon or something different, put something different. I don't care, whatever you want to do. But there's just some easy examples. A triangle, we've done, gosh, I want to say 2 full chapters of triangle work. A triangle is also considered a polygon, 3-sided figure. Quadrilateral, 4-sided figure. Octagon, 8-sided figure. So that's what we're going to talk about. All right, we're also going to talk about a diagonal, of course, is a segment that joins 2 non-consecutive vertices. In other words, a line segment that connects 2 vertices but isn't a side of a polygon. So of course, diagonal is just what you think of when you draw it through the middle of the figure. Like we had the diagonal of a rectangle. We saw that a lot last chapter, which split your rectangle into 2 triangles. So diagonal is always, the book I think makes things sometimes wordy and complicated. Diagonal is exactly what you think of when you hear the word diagonal. Okay. Now, some other vocab. Types of polygons. So the first one, of course, and I gave you a picture, you just have to fill in the blank. Equilateral. We've seen that vocabulary word equilateral. Of course, all the sides are congruent. So that's the next blank you're going to fill in. You know that. We've seen equiangular. All the angles are congruent. So angles is the next word to fill in. Now, this last one is probably new. We're going to start seeing the word regular a lot, a regular polygon. That means, of course, that all the sides are congruent and the angles. So you're filling in, I did yours short and sweet, regular polygon, a polygon with all congruent sides and congruent angles. And don't forget, if you just want to use the congruent symbol on your blanks, you can. Okay. So that's what you're filling in is congruent on those 2. So when you see regular, all sides, all angles, congruent. It's equilateral and equiangular. We've seen that vocab when we talked about triangles. Okay, so 2 things we're really focused on today. How to find the measure of an interior angle, one of these angles, and we're going to talk about exterior angles in a minute. So the first formula that you're going to write down that we're going to talk about that's easy. So the interior, because I'm going to switch it up to exterior. The sum of the measures of the interior angles, that's what you got to fill in on the blank, of a convex n-gon, and the formula is on there. You don't have to write this. I just want to point it out and draw your eye to it. I'm going to talk about that formula in a second. So many good vocab words here, okay? So again, if I want to find, notice it says another key word here, sum. If I want to find the total of all the angles inside, I just take my number of sides. So on this one, there's 6 sides, of course. And you would do 6 minus 2 times 180. That would tell you how many total degrees are inside the polygon. Now, as always, we got a lot of vocab here. I've thrown out a lot of vocab words already. We talked about octagon, hexagon, triangle, all the things. Let's talk about some of our common polygons. Do you have to have this whole chart memorized? No, but there are some obvious ones that I think we should know. I'm not underlining triangle. You know triangle, okay? We know that. We got it. We should know, of course, really all of these. This section here, which again, I think you probably know a lot of these. I'm pretty sure you knew 5 was a pentagon. That hopefully that's familiar. 6, hexagon. 7 might be kind of new. That's not used quite as often. 7 is a heptagon, octagon, decagon if there's 10 sides, dodecagon is 12. So of course the ones on the left side are your more commonly used names that you'll see those a lot. Of course, I'm going to see this. You see this one sometimes too. So 9 is a nonagon. Now, we got some crazy good vocab words here. Notice, it's not every single, I mean, we go from 20 to 30 to 40 to 50. You can have a figure with 21 sides on it. Really hope we would never have to draw such a thing, but you can have a figure with 34 sides on it, okay? Once you get to those larger numbers, even like 14, I don't expect you to memorize tetradecagon, okay? You can just call it a 14-gon or a 15-gon. That's kind of the generic way to name those, and that's what we're going to use too. So I really only expect you to know the left-hand side over there, and probably, I would say on that left-hand side, the ones you probably aren't as familiar with, heptagon, decagon, and maybe number 12, dodecagon. So those you might have to work on practicing. All right, here we go. Let's do it. So super easy. Flip the page. Find the sum of the measures of the interior angle of the figure. Okay, so we are using that formula that you just had, n minus 2 times 180. Super easy. I'm just going to put the formula so it's in front of your face. Okay, here it is. Super hard. Get ready. Count the number of sides on the picture for me. How many sides? 8. So all we're going to do is we're going to put 8 in here for n. So, of course, you can punch that directly as it appears in your calculator. Really, let's make it smart. Mental math, that's what's 8 minus 2. 6. I would just do 6 times 180 in my calculator. Okay, punch that in for me. Perfect. So that is the sum of all the angles inside your polygon. This is what you're doing today, my friends. Love it. Okay, questions on that one? No, there's not. So, sum of the measure of the interior angle of the polygon 900. Classify by the number of sides. Okay, little twist on this one. So this time they gave you the total. I know it's supposed to equal 900. So when I go to do my formula this time, I'm going to have 900 equals n minus 2 times 180. Now, you have to solve for n, which is the number of sides. Okay, we're going to do a little algebra. Big deal. We can do some algebra. Now, my gut instinct is, oh, I'm going to distribute 180. I was like, well, wait a minute. No, I'm not, actually. I'm not going to do that. Because distributing doesn't really get rid of the 180. You can distribute it, sure, but it's not getting you anywhere. I'm going to get rid of it and just divide it off. Okay, punch that in your calculator. What's 900 divided by 180? Got it. Now from here, you can just do a little mental math. How many sides? What's your final answer for n? 7. Got it. So we're going to have 7 sides. That's easy. Okay, classify by the number of sides. So it wants the fancy name for a 7-sided figure. So again, this is the one you're probably not as common with. I'm going to click it back so we can spell it, maybe, hopefully correctly. I'm going to write heptagon for it. And I'm going to circle that. This seems too easy after all of that log cosine work. Okay, sum of the measures of the interior angles is 2,340, classified by the number of sides. So same thing, you want to figure out what n is. So you know the sum this time. We're solving for the n. Now again, you can distribute 180, but it really doesn't get you anywhere, so I just feel like it's extra work. I'm going to get rid of 180. I'm going to cancel it and divide it. All right, calculator, what's 2340 divided by 180? 13. A little mental math here. Final answer for n. 15. Now, no fancy name that we have to memorize. I mean, it's on the chart, but you don't have to memorize past to know 12. So I'm just going to go with the generic 15 gon. This is what I'm going to name it. That is as difficult as it gets today, my friends. All right, let's look at the next picture. So corollary to this, of course. So sum of the measures of the interior angles of a quadrilateral is 360. Now, to me, this is like, okay, well, yeah, this makes sense. If you're like, oh my gosh, I'm never going to remember all of this stuff. Well, this is the same formula. How many sides on a quadrilateral? 4. So if you use your formula, isn't 2 times 180, 360? So it's just telling you, of course, because we're going to see more quadrilaterals. Remember, the theme of this chapter eventually kicks into really specializing on quadrilaterals. We're going to, of course, just now always know it's going to be 360. But if you're like, oh man, I can't remember that, well, use your formula. Do your n minus 2 times 180. You'll get it. Okay, so here we go. Find the value of x in the diagram. So we know the sum is 360. If you do your n minus 2 times 180 like I just did, you get 360. Okay, now you probably can just do this mostly in your calculator, but you know I love to show work. We're going to add up all the angles, plus the 121, plus the 59, and it should equal 180. Now, majority are probably not doing a whole lot of work here on your calculator, because if you want to get x alone, you're going to have to subtract 108, subtract 121, subtract 59. In my calculator, I would have just done, why did I write 180? Not 360, guys. I'm sorry. I got excited about my subtracting here. I wrote it up here. I didn't put it there. Okay. So I'm going to, in my calculator, I really wouldn't do any more work. I'm going to do 360 minus 108, minus 121, minus 59. I'm just going to do this all in my calculator. Final answer for x. What do you got? I like it. Too easy. I'll put a degree symbol on. This is as challenging as it gets today, everybody. Okay, picture time. We got a very lovely little home plate for the baseball field. So first question, good vocab. Is the polygon regular? Now remember, regular means, that's a new vocab word. We haven't seen it before. You know these two though. Regular means equilateral and equiangular. So is it regular? No. Okay, so for part A, okay, explain your reasoning. I'm not going to get crazy here. I'm just going to say not equilateral. You know I love to use good vocab. Not equaling. All the equals. Okay, good. Let's do B. Find the measure of C and E. Okay, all right. Well, obvious stuff here, obvious. C and E are congruent. So I'm just in the picture, I'm going to label them X. You can label them whatever variable you want. I know we like X in here. And obviously you know that these are your right angle symbols, okay? Now before I get into anything, I need to know the sum. What should be the total of all the angles? Well, do a quick count for me. How many sides are on that figure? 5. So the first thing I'm going to do is 5 minus 2 times 180. Okay. Punch that in your calculator. Total of 540. Now, everything inside there should total to 540. All the angles. Now, some of you, of course, you're probably going to do this in less work, but you know I love to show work. So I'm going to start at the top. I'm just going to go around A, B, C, D. So A is 90. B is 90. C is X. D is 90. E is X. Now, we're just going to solve that equation, of course. You're going to combine, of course, your X and X. Hopefully we can do this without a calculator. What's 90 plus 90 plus 90? 270. I'm going to scroll this up. Okay, take it from there. Subtract your 270, divide off the 2. You can do it. Final answer for X. 135. Piece of cake. All right, any questions on that? Okay, next picture, kind of similar, just, you know, different amount of size. So find the measure of angle S and the measure of angle T. So again, I see these are congruent, the red arc marks, so I'm just going to call them X and X. First things first, let's figure out the total. Count it, look at it. How many sides are on that picture? 5. So again, we're going to do our 5 minus 2 times 180. Now, just luck of the draw, this is 5 and the last one's 5. They're not all 5-sided figures. I'm just going to steal the 540 there. We already calculated that. Okay. So everything inside of there should total to 540. So my 93 plus my 156 plus my 85. And I know a lot of you, and I'm with you on this, is it worth me writing X plus X really, or should we just combine it? How many X's do you have? 2. Let's just go to 2X. And we know that should equal 540. Okay, I'm going to give you a second to solve it. Don't even need a full second there. I hear people still typing in the calculator, so let's see if we agree or disagree. All right, what do we got? I heard some answers. Are we still typing? I heard something. 103. Is that what everybody has? I like it. I agree. Okay. All right. So this is anything and everything you could possibly do for interior angles. N minus 2 times 180. That's as wild as it gets. Okay. Exterior is actually even easier, if you ask me. So first, let's talk about what an exterior angle is. There's nothing for you to draw on your paper. I just want to point out what an exterior angle is. So of course, mine are in blue and red here. So exterior angles, just think about the vocab word. They are on the outside of the picture, the outside of the polygon. So they just labeled some of them. I mean, it could be any of these, any of them. Any angles on the outside are exterior, okay? Now, if you take those exterior angles, that's the next picture, what they're showing you. If you take, notice just one, not all of these, I just picked one on a corner, one on a corner, one on a corner. If you take those and you total them together, notice you get 360 degrees. So I'm going to click the slide, but that's going to be the first blank I'm going to fill in there on the exterior angle theorem. The sum of the measure is 360. There's no fancy formula. You just know it's 360. So that's the first blank you're going to fill in on polygon exterior angle theorem. Now, if you look at the picture, I love this, such good vocabulary, because they're going to have you talk about an exterior, like number 5, and an interior angle. Vocab time, I love it. So these two angles make a line. Do you remember their fancy vocab name from first semester of pair angles that make a line? Linear pair. So notice an exterior and an interior form a linear pair. So you're going to fill that in. So we're going to use some of that knowledge. Remember, we always say geometry is the gift that keeps on giving. All of a sudden you see some stuff from first semester. Linear pair. Okay. Therefore, the sum of an exterior angle and an interior angle. What's a linear pair equal? What's a line equal? 180. So that's your next blank you're going to fill in. So I'm going to use all of that very lovely information. So two things really you got to take away from this section. Interior, n minus 2 times 180. Exterior, they total to 360. That's it. Okay, so let's look what we got. Find the value of x in the diagram. Okay, so notice your angles. Looking at all my angles here, are on the outside. They are exterior. So they are going to total to 360. So I'm going to do the same thing as before. We're going to add all of these up, the 2x, the 89, the 67, and the x. In any order, of course. And we're going to solve that equation and solve it for x. Of course, we're going to combine our like terms. You guys can take it from here. Let me give you a minute to solve and let's see what we got. We should get 68. Because, of course, we're going to combine our 89 and 67 there. You should get 156 for that. You're going to subtract 156, divide by 3. You guys are great at solving equations. You don't need me for you. So interior, n minus 2 times 180. Exterior, 360. That's what you have to memorize. Okay. Convex hexagon has exterior. Okay, as soon as I see the exterior, I'm already thinking 360. Okay, I'm going to keep reading. I'm going to keep reading here. With measures 34, 49, 58, 67, 75. What is the measure of an exterior angle at the sixth vertex? Now, remember, this is the same thing. It's just very wordy. Hexagon. How many sides on a hexagon? 6. You know that. Okay. So notice they gave you 1, 2, 3, 4, 5 angles. You got to figure out the sixth one. So again, most of you can probably do this all in your calculator, but you know I love to live for work, okay? So I'm going to do 34 plus 49 plus 58 plus 67 plus 75 plus my unknown sixth angle, which I just called x, and it should total to 360. Let me give you a second to solve it. Super, super easy. I like it. You get a final answer of 77. I've got 77. We should get 77 for it. Got it. Too simple. Any questions on that? All right, we just got last couple little fun, fancy ones for you. I'm going to give you your quizzes back from yesterday. Okay, find the measure of each exterior and interior. Okay, all right. So they want both. Interior and an exterior. Okay, all right, we can do it. First question for you, this. Decagon. How many sides on a decagon? 10. And again, you've got the list of all the sides there in your notes. If you're like, oh, I forgot, look on your list. Okay, now it doesn't matter if you do exterior, interior first. There's lots of ways to do these problems. I'm going to show you my easy hack, easiest way, non-book method to do it, okay? I'm going to start with exterior. Now, here's why. Exterior totals to how many degrees? 360. And if I want to find each angle, I'm going to take 360 and divide it by 10. That will give you each individual angle. Okay, we don't need a calculator for that. What do you got? 36. So each exterior angle is 36. I'm just going to label. Now, I'm going to use some old school, easy knowledge. This is why I added this onto your lovely notes. We haven't used this yet. I'm going to click it back. Notice, each exterior, interior, easy, make that linear pair. Bam. If I want the interior one, now I know those should make 180. Linear pair postulate, throw back there, okay? So my interior one, I know should be the exterior plus whatever the interior is, and they should make a linear pair of 180. Well, most of you can probably just do that on your calculator. What's 180 minus 36? 144. I can't really even say I would have shown a lot of work for that, but that's how I'm going to do it. So that's the easiest way to do it. Get your exterior first, because they're going to make 360. That's super easy. And then just the two of them combine to a linear pair, 180. Okay, so let's try this one. Classify the regular polygon and the number of sides of each of the interior angles has a measure of 140. Okay, so first off, and I'm almost off the screen, they tell you the interior. It's easier to work off the exterior. So let's do a little mental math here. Okay, if the interior angle is 140, what's the exterior if they make that linear pair? Quick, easy. 40. They got to make 180. Okay. So now I know my exterior is 40 because these total to 180 or linear pair. Super easy. Now, to get a course, it wants the number of sides. Well, we can do that. Exterior, what's the total of all exteriors? 360. So then I'm just going to equally divide it by 40 to figure out how many sides on it. Well, you can do that in your head. What's 360 divided by 40? 9. And then, of course, classify. It wants a little special fancy name for a 9-sided figure, which is a nonagon. And we got it. Okay. So this is the only quote-unquote tricky part of the day. try to work when they need both, work with the exterior and then just linear pair to get your interior. And I know we love standardized tests. Yeah. Okay, all right, and the triangle above, A is 34. Okay, I'll put 34 right here. Got it. What's the value of B plus C? Well, that's going to be super easy. You know this. All three angles in a triangle add up to what? Okay, so do 180 minus 34 for me. Now, isn't that what B and C should combine to is 146? Okay, circle 146 and we're done. I'm going to put a degree symbol on so it looks fancy. There we go. Okay. Any questions on that?